Okay, so recently you learned of what the derivative is, being a function of a function, teaching you the slope of a function. Finding the derivative can sometimes be very easy if you know the right rules, and that is what today's lesson is, and it's the derivative rules. There's the product rule, the quotient rule, the power rule, and the chain rule. Power rule being the easiest, all the way to the chain rule being the hardest. Learning these rules will help you become better at getting the derivative and make calculus much more easier. First off, we're going to start off with the power rule. We taught you way in the beginning how to do this, but we're going to go back at it again. The product rule goes like this. If x to the n is your function, and you want to take the derivative of that, the definition of the power rule is nx to the n minus 1. And that is how you do that.
So you just drop it and subtract it from the power.
You take the n, drop it in front of the x, whatever this is, multiply it by it, and the n. For example, if you had a x squared, it would become 2x because you drop down your 2, making it 2x, and you subtract 1, and you have a 1 up here, but you don't have to write that. Another example is 3x cubed. You would drop your 3 down, and that would become a 9 because you multiply the 3 by 3. You have your x, and you subtract 1, and you get 9x squared. This is the power rule.
In a nutshell.
In a nutshell. That's really all there is to it. There's nothing more extreme to the power rule other than if you get like 4x and you do that, you're only going to be left with 4 because this is really 4x to 1, 4 times 1, x minus 1, x is 0 is 1, multiplying all together equals 4. You should know that. Anyways, next up, the product rule. The product rule states like this, U and V. We'll name this 1 and this one 2. The product rule is actually, the definition is much longer, but I'm going to give you the shortened version, and it's basically 1 prime 2 plus 2 prime 1. Basically meaning, if you, or whatever this function right here is being multiplied by another function with different variables, or to a point where you don't want to, or the chain rule comes along, you can use the product rule to simplify your time. So U is our first one. You would first take the derivative of U and multiply it by V, plus the derivative of V times U. So this would look like U prime V plus V prime U. This is your product rule.
Let's just give them an example.
You'll get examples at the end of this of everything. If you really need to, skip on past the video, past all the teachings. Don't really know exactly where that's at in the video, but good luck. Anyways, next one up is the quotient rule, or your division. If you were given two variables like U over V, or it could be like x plus 1 over x minus 1, what's the derivative of that? Well, the rules stated as follows. We would say, we can be safe to show that this is the high and this is the low. And the rule rhyme goes low derivative high.
D high.
Low D high minus high D low.
Over low low.
Over low low, which equals out to low squared. So, nice you know your little rhyme. Low would be V. And it's not the derivative, so we can just put this. Derivative of high is U prime. Subtract. Now you have the high, which is just U by itself, and the derivative of low, which is the derivative of V, over
V squared.
That is the simplified quotient rule without going into a massive definition of it. And that's really all you really need to know. You're never going to need to know the definition or anything. Just know how to do that. And that is the quotient rule in a nutshell as well. The final one, which is going to require its own sheet of paper, is the chain rule. A lot of people get confused by this, but it's pretty simple. Let's take x squared plus 1 squared. Now, you're probably wondering, how do I do this? And this is where the chain rule comes along, because there's two things you have to do here. We're going to make the inside, we're going to make the outside f of x, which equals, we'll see what it equals in a second. We'll make the inside g of x, which equals x squared plus 1. Alright, f of x equals g of x squared. Alright, g of x could be something else, but that f of x is the outside function. So we have the two. How do we do this? Well, first, you do this, and you do f prime of x. Now, what is f prime of x? Which could just in the beginning complicated me, but here's what it is. f of x is g of x outside. We know whatever the outside is the outside definition of f of x. Take away that squared. Like, this could be anything. This could be cubed. Let's make that cube just for the heck of it. But this could be cubed for all you know. But f of x is the outside function of it that makes it to become the chain rule. So you take f prime of x, and this equation, that would become 3x squared plus 1. You do the simple chain, you do the power rule here, but you keep your g of x the same. The outside function pretends like this is just an x by itself. Then, what do you do with the inside? Because this, the derivative of this, is definitely not this. So, then you do g prime of x. Now, this doesn't look like this at all, but in reality, it would look more like 2x, because x squared plus 1, if you know your power rule, is equal to 2x. This derivative is right here. You could multiply all this back out into each other, but this is the simplified version. This is not the simplified version, but this is the simplest version I can show you without going into more detail. It's very complicated and takes a lot of practice to get the chain rule down, more so than the others. This is why it is the hardest. We have a couple practice problems over here, and we're going to start out with the product rule. The power rule, I'm sorry. So we have negative x squared plus 3. So we take the derivative, and we get negative. You keep your negative. You have a negative 1 there. That's your constant. It stays there. You bring down your n. And negative 1 times 2 is negative 2. Keep your x, and you subtract 1 from your 2, and you have a 1. Don't have to write that, whatever. This is a 3 to the 1. We can be safe to say that due to our rules of algebra. And if you multiply that 1 down, you get a 3. That becomes a 0. Anything to the 0, this goes away completely. That goes away completely. If you do not have if a constant is taking the derivative of it, it is automatically 0. Because you learn that the derivative of a function is its slope. And if you have y equals 3, the derivative of so is a flat line, which its slope is 0. So you have negative 2x. Simple power rule, not hard to understand. Next is our product rule. 2uv equals y. So 1 prime 2. These two right here can be 1, and this one can be 2. So 1 prime, which is going to be 2u prime v, which is 1 prime 2, plus 2 prime v prime 2u. That's it. U and v could be something, but that's the simplest I can give it to you. Practice the problems to get better at them. That's the only way you can get better at math. Next up, the quotient rule. 3u over v. Remember the little rhyme of low d high minus high d low. The low is v. Low d high, the derivative of the high, which will be 3u prime, minus high d low, our high being 3u v prime, over low, which is going to become v squared. U and v can be their own functions in one function, but this is the simplest again. Now's the chain rule. 2x minus 1 squared. Best to help you out in the beginning is do f of x equals the whole thing, which is g of x squared. And g of x equals 2x minus 1. So it's f prime of x times g prime of x. F prime of x is this right here. So doing our power rule, we get 2 times 2x minus 1 being g of x. And then 2 minus 1 is 1. So you don't have to put anything there. Times g prime of x, which is equal to 2, knowing our power rule. Multiply this all out together, you get 4 times 2x minus 1, which becomes 8x minus 4. And that is the derivative of 2x minus 1 squared using the chain rule. Now a little bit more complicated chain rule is 5x times 2x minus 1 squared. You gotta remember, what is f of x and what is g of x? You also have to use the products rule here. When you start using two different rules at the same time, you could at some point be using all four at once. So first let's figure out what our f of x is for our chain rule part, which is equal to g of x squared, because we have a squared right here. G of x is equal to 2x minus 1. We also have an outside function, which is going to be 1, and this one's going to be 2. So 1 prime 2, product rule first, 1 prime 2, which equals 5 times 2x minus 1 squared, plus 2 prime 1. We'll put our 1 first to save us some time. Now you have to do your chain rule. First is f prime times g prime. F prime is the other one over here. So you bring it down, and you get 2x minus 1. You still got to take the derivative of the inside or of g of x. So multiply by that, and you get 2. Which we know this whole thing comes out to be 8x minus 4. So we got 5 times 2x minus 1 squared plus 8x minus 4, or 5x times 8x minus 4. And you could come pull this all out, but this is the derivative using the chain rule and product rule of this. That is basically that's the 4 rules of the derivatives. Practice these with any math you know, just getting out certain things, and that is all for the rules. Take care.